Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at Graphics Windows. Today we're going to be looking again at the graphics window. As we want this application to be able to be run either in the console or the Windows compiler, we're going to put a little bit of code in here to turn off the console if we're running under the console compiler. So with this piece of code in place, if we are running under the console compiler, the console will not appear. So within our PB main function, we want to create and display a graphics window. All graphics windows require a handle by which you can control them, so we'll declare a local variable for that handle. And we can use the graphics window command to create our graphics window. We're going to reuse a piece of code we used in a previous program to set the Windows position to be topmost. This is using a Windows API call. This will ensure our graphics window is visible to the user and it will appear on top of all other windows. As we've now displayed the graphics window, we want to use the graphics attach command. This instructs the application to direct all graphics commands to this specific window. And we're using the redraw option to buffer any commands going to the graphics window, not to be displayed to the user until we use the graphics redraw command. So this would display a graphics window on our monitor. So having displayed this graphics window to the user, we'll want to display some text upon it. And to make it easy to see, we're going to make the text a little bigger by setting up a font. So we will declare a local variable as the handle for our font. And we're going to use the font new command to specify that the font we want to use is Courier New 18 point. We're next going to clear the graphics window, set the background to be light grey, then use the graphics color command to set any text going to that graphics window to be a foreground colour of black and a background colour of light grey to match the background of the graphics window. We're then going to use two graphics print commands to print two lines of text to the screen. However, if we ran the application as it stands, it would end almost immediately. Because once the graphics window had been displayed, there were no further commands in the PB main function to execute, so the application would end. So we need to put a loop in at the end to wait for the graphics window to be closed by the user. We can do this quite easily by using another Windows API function called isWindow. This takes as a single parameter the Windows handle we had created when we created a graphics window. So we're running around this little loop every second, testing to see whether the window has indeed been closed. So if we try running the application now, we will see our graphics window successfully appears on the screen. It has displayed the two lines of text and it's now waiting for the user to click X on the top right hand corner of the graphics window to close the window. As you will see in the taskbar, there is an icon showing for our graphics window. If we close the graphics window, it will disappear from the taskbar, so the application has now terminated. However, as you will have seen, the icon used for the application and on the graphics window itself is a default graphic. What if we want to replace that with a graphic of our own choice? Well, in the folder, I've created an icon called Grid Icon. We're going to use this icon both for the application and for the graphics window itself. This can be done quite easily by using another Windows API call. Before we display the graphics window to the user, we're going to make a call to this Extract Icon API. The Extract Icon API call takes three parameters. The first parameter is for the module handle. If we use getModuleHandle and as its parameter an empty line string, it will get the module handle of the application we're currently running. Next, we give it the name of the icon we wish to use. Finally, we give it the parameter 0. This will return an icon handle, and we can use the sendMessage command to set that icon as small on the graphics window itself. So as we're going to be using another handle, we'll need to declare this one up at the top of our function. So if we run that code now, we will see our graphics window now has an icon on the top left-hand corner of the window, and the application on the taskbar also has the same icon. So we have successfully created a graphics window for our application. But what if we want to create a second graphics window? How do we go ahead and do that? As we've done before, we use the graphics window command. So we're setting up a new graphics window with the text second graphics window, and we're passing it to another handle, in this case window 2. So we will declare window 2 at the top of our code. So we now have two handles for our graphics windows. As we've done before, we're using the setWindowsPosition API call to make the window topmost. And as we've done before, we need to use the graphics_attach command to instruct the application to direct all graphics commands to this new window using the Win2 handle. So we're setting the font to be the same font as the first window, we're clearing the graphics background, and we're printing the words more data to our second graphics window. We can then use the graphics redraw command to draw the graphics to our second window. If we try running the application now, so we can now see there are now two graphics windows on the screen, with the second graphics window having the text more data. The user can then move the graphics windows around the screen quite happily. Should the user close the second graphics window, the application continues to run, because our code is specifically looking for the closure of the first graphics window. So having displayed two graphics windows, what if we want to put more text onto the first graphics window? We can reattach the first window by simply using the graphics_attach command again, and the handle of the first window. We can then print some more text to that first window. And to ensure the user gets to see this, we can use the graphics redraw command to display that on screen. If we run that now, we will see our both graphics windows have appeared, and the first window has indeed got yet more data on it. Since we're looking at the first graphics window, any attempt to close the first graphics window will of course close the other graphics window and terminate the application. So what else can we do with graphics windows? Well, to do this next part, I'm going to add another library. I'm going to add the graphics_progress library, which we covered in a previous video. This one is designed to display a progress bar on the screen for the user using a graphics window. So as this is going to be a third graphics window, we will need yet another handle. So we've now created a local variable for this third graphics window. We're now going to call one of the functions within the new library we've just added. This will open up a graphics window with some text on it and a progress bar. This will position the graphics window at the coordinates 100 by 400 on the screen. These are relative to the top left-hand corner. As with all the other windows, we can use the setWindowsPosition API call to ensure that it is displayed to the user on top of the other windows. As this is going to be a progress bar, we want to call a little function to display some progress on the window. So we'll create a new function called reportProgress. And this function takes no parameters, as it will be writing to the current graphics window. So this is a simple for next loop. We're basically displaying a progress bar moving up 10 steps, 10% of the work for each step. And we're also displaying a message on the screen saying still processing, and when it gets to 100%, it will say completed processing. Between each step, we're doing a delay of 500 milliseconds to simulate some processing going on in the background. And we're calling another function within our new library to update the graphics progress on screen. And at the very end, we're sleeping for another half second, and then we're closing down the graphics window. So if we try running that code now, we will see we get a progress bar appearing on the screen. And after it gets to 100%, it will terminate. So we've now successfully displayed 3 graphics windows on a user's screen. But can we do even more on graphics windows? Let's assume we want to load an image onto the first graphics window. We can use the graphics render command to actually render a bitmap to the screen. However, we have here in our folder a JPEG. This is the image we want to load onto our screen. But you can load a JPEG directly onto a graphics window. So we're going to add another library. This library is called pbload_jpeg as bitmap and contains all the functionality to take a JPEG and hand you back a handle for a bitmap. And once we have that handle, we can quite happily load the memory bitmap onto the graphics window. So we're going to need some variables for this one. A width and a height variable for the size of the bitmap we've actually returned, and also the handle itself. We're going to be calling a function called loadImageFile, which is in the new library. This takes one input parameter and has 3 output parameters. The first parameter is the path and the name of the file we wish to load, in this case map.jpg. The 3 output parameters will return the width and the height of our bitmap, and the final parameter is the handle to the bitmap itself. So should this function return true, in which case it has successfully loaded the JPEG and turned it into a bitmap, we want to use the graphics attach command again to ensure we're attaching and writing to the correct window. Having done that, we want to use the graphics copy command. This will copy our bitmap onto our graphics window. The graphics copy command has several options. In this case, all we're doing is taking the bitmap we've loaded and positioning it at coordinates 100 by 100 inside the graphics window. This will display our graphic to the user. Having completed the copy, we can then use the graphic bitmap end command to free up the memory used by working on the bitmap. Then we can use the graphics redraw command again to display the bitmap to the user. If we try running that code now, we will see our progress bar appears as before, and once it has completed, we will display the bitmap to the user. So our JPEG has now been rendered as a bitmap on the first graphics window. So in summary, what we've achieved today is we have used graphics commands to create 3 separate graphics windows on the user's monitor. 2 of them have text. The third is set as a progress bar. And we have additionally positioned a JPEG as a bitmap on the first graphics window. So using these commands, you can create quite a sophisticated graphics set of windows. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.